very excited to be here and presenting this material today. So hopefully we'll all learn something and enjoy our time together. Today's talk is about building smart contracts with Ethereum, and my name is Monette Stevens. My email is monette@sfgrowthlabs, and my LinkedIn profile is pretty easy. It's just my first name and my last name. And I'm teaching with Develop Intelligence right now, and Develop Intelligence provides all kinds of technical and other types of learning sessions, both for corporations directly as well as for the public. So I encourage you to go check them out. There's a lot of interesting things that we provide. So just to start out, I just kind of wanted to go through what we're going to be covering today. So we'll have a little bit of conversation that I'm going to try to get through pretty quickly about blockchain and Ethereum, excuse me, and Solidity, which is the programming language which we use to write smart contracts. And so we'll talk a little bit at the beginning about cryptocurrency and Bitcoin and Ethereum and why Ethereum even evolved. So if there are any questions, please feel free to reach out. If there's anything specific that you want to learn today, let us know so we have a heads up. I'm going to go through an idea, some blockchain ideas, talk a little bit about the Azure Blockchain Development Kit. We're going to be looking at writing some smart contracts in Ethereum using VS Code, and I'll go through and build an example called Blockopoly, which mimics Monopoly. Just as a heads up, the normal session, which we would do with the reactors, this whole thing was designed to be an entire day with interactive labs that are happening, throughout the day. And so normally we would build this whole thing up over the course of a day. And so this has kind of been compressed down a little bit. So I'm just letting you know. But if there's anything additional that you want to learn, please feel free to go to the Microsoft Reactor section on GitHub. We will provide that for you, the link to that. And there's a number of examples and sample code and instructions on how to write smart contracts and get through all of the stuff that we're doing today. It's all available on GitHub. You can, clone it and install all the tools. All the tools I'm going through today are free and available on the web, so you don't have to pay anything to do that. All right. So the example that we're going to go through a little bit later in the lab is a game that is modeled on Monopoly, and to keep the concept relevant, we're going to use Microsoft reactors both here and in the future as locations, and the pieces are going to be themed according to cryptocurrency, so Bitcoin, Ethereum, Monero, Zcash, Ycash, and Stellar. Just to kind of talk a little bit about what we're going to do a little later is with this game, again, similar to Monopoly, which was originally designed, I believe, I don't know this for a fact, but I believe to teach kids and other people how to manage and handle money. And so it's really relevant for an example, for smart contracts, particularly since so many of the early dApps and the platforms that are being developed, with Ethereum smart contract do have financial financial instruments or financial applications in mind. So there's lots of trading, etc. So the roles that we're going to be developing in the example that we're going to go through is, those of a banker and a bank, and assets. And assets in Monopoly can be properties or money, and it's kind of similar to what we're going to be doing here. So the behavior of the game is to manage money and properties, and the comings and goings of of players in the game. And when you do play Monopoly, if you have experience playing it, you would probably, usually one person is designated as the banker, and so, but that banker is also a player. So, the question that comes up, and this is one of the reasons why we decided to use this example, is it exhibits this idea of having essentially an idea of trust, but when you're having to operate with multiple parties who you don't necessarily trust or don't necessarily know. So the trust is going to be built into the game and enforced through the rules of blockchain. So, all right. So one of the terms that I use all the time, which I really didn't ever use prior to getting into blockchain, is the term fiat currency. So fiat is a government issued currency, and we're all probably familiar with different fiat currencies, dollars, euros, yen, rupees. So depending on where you live, British pounds. Most governments, and I'm saying most because there are some governments that have either pegged their money to other currencies or use other currencies, but most governments have their own currency, and it's not necessarily backed by a hard asset such as gold or silver, but it's backed by the government that issued it, and you're essentially putting your trust in the government. And the fiat money is then used, by the population, banks control it, etc. But, one of the dangers is that if governments print too much of it, or if there's, any kind of, governmental problems going on, like we've seen with, for example, with COVID, issues with inflation or devaluation, et cetera, can become problems. But similar to how digital currencies and Bitcoin initially was being used, cash, for example, which is what fiat money is, actually does allow for anonymity and offline processing. But with this system, you need to have a way to get cash and transfer it and use it. So that's kind of a little description of fiat money. The reason why I wanted to really talk about it in that way is, what has evolved with cryptocurrency and particularly Bitcoin and other types of cryptocurrencies is really an alternative to traditional cash-based systems and traditional fiat currency. We've seen one step closer to digital currencies or digital finance with credit cards and banks and other types of transactions. So, with these other types of alternatives, associated with them is usually risk, because if you're using your credit card, you are not allocating the resources at that moment. You are using the credit that you have on your credit card basically to say that you're going to pay this back. And there are high transaction fees oftentimes with credit cards, or you're having to give your details to an intermediary. So, these are some of the reasons why digital currencies, evolved and have come into play. So cryptocurrencies, and I'm assuming most of you that are here today, because you're interested in this, have evolved as an attempt to solve, some of the problems that were encountered with fiat currencies and with the use of digital assets. So we have seen an explosion over the past decade of different cryptocurrencies. Blockchain, not blockchain, Bitcoin was launched, I believe, in 2008. And we'll continue to see more use of blockchain technologies and cryptocurrencies moving forward. What we've seen, I've been personally involved with digital assets and cryptocurrencies and distributed finance for quite a while now. Specifically, I've been involved with companies that were launching in the crypto space, both blockchain companies that aren't necessarily token or currency related, some of the infrastructure for doing issuances. And also, one of my other areas of expertise is working with different jurisdictional regulatory constraints. So as digital finance with decentralized finance, I should say, with cryptocurrencies has evolved, so has the need to actually put regulatory constraints around that. So that's one area that has been evolving over the last several years. And I'm not going to go into too much detail with that, but those are some interesting areas to look into if you're interested. And there's a lot of information on that on the internet. But what really makes cryptocurrencies, valuable is that we need to address the problems of scarcity and resource allocation. And we also need to address the issue of trust, because when you do have a decentralized ecosystem that doesn't necessarily have, a entity that is managing and controlling it, there needs to be a mechanism by which we can do that. And one of the things that's been, interesting, I think personally with Bitcoin and my personal journey of getting familiar with and learning about blockchain and cryptocurrency was getting over that first part of the hurdle, which is, how it actually works and what it actually means to, hold a token or hold a Bitcoin. And, how can I trust that? And then how can I go on and connect with other people and, and trade that in a way that is secure and has, that I can trust. So, one of the things that, or one of the foundations of really when cryptocurrency first came, to the public and onto the market, was this paper that was written by Satoshi Nakamoto. A few years ago, I was at a conference and there was, at the time, a lot of people were talking about, who is this mysterious Satoshi Nakamoto? We don't really know who he or she is. There's a group that was posting or printing out a bunch of T-shirts that said, Satoshi is female, which of course I bought. But we don't know if Satoshi was actually or is actually a person or, a group. It's been theorized that the author of the white paper was more than one person, but the white paper, what it did provide was the premise for consensus theory and the working code. So if you do have a few minutes and you do want to look at it, it's a pretty readable paper. You can just Google it. It's available pretty easily on the internet. I didn't provide a link here, but you can find it pretty easily. But it was actually built on previous cryptocurrency ideas with a few new tweaks that had to do with the consensus methodology that's used to commit blocks to the blockchain. There were some previous ideas that it drew upon, and one of them was David Chaum's eCash, which people considered really the first electronic or cryptocurrency that was out there. There are some other people who also had early versions of cryptocurrency as well. And, Bitcoin and the paper actually solves the problems of centralization, double spending. So when you do a transfer, you need to wait until the commit has happened to make sure that it doesn't you don't do one transaction, another transaction. So all of this is built into committing blocks onto the blockchain and using the consensus methodology. So the consensus methodology for Bitcoin is called proof of work. And proof of work is, relatively process intensive. So it, sometimes can take several minutes, sometimes even longer, to commit a block to the blockchain. So, when you get a Coinbase account, for example, and set up a wallet and buy some Bitcoin, you make the request for the transaction, but the actual transaction has to clear the actual Bitcoin blockchain. And so that takes a few minutes to sometimes even a little bit longer. So, if you are interested in this, you can just go to bitcoin.org and look at the paper, as well as look at blocks on the blockchain, etc. All right, so what is it that Bitcoin is? And really what I'm going to talk about right now isn't specifically Bitcoin as much as a model for cryptocurrency. Bitcoin is an implementation of that model. So Bitcoin is actually a protocol established on a peer-to-peer decentralized network. There is no one person or no one entity actually controlling it. It's a public distributed ledger of transactions. There are rules for validating the transaction. It's really straightforward to get started participating. I mean, really, you can get you can set up a hardware wallet, you can buy something like Ledger, or you can set up a software wallet. And with your wallet, when you set it up, you'll be setting up both public and private keys. So your public key, there's some links I think that we have provided on the Reactor, in the Reactor GitHub, in one of the READMEs at the very top of that tree structure, has links that I think are really useful to go and look at. That talk about some of these ideas in more detail, but specifically has a link that talks a little bit more about cryptography and public and private key encryption. So we're just going to touch upon that here so we can get into an example in a few minutes. All right, so just a little more information is that, one of the foundations on this is that there are consensus about rules and consensus about the history, and this is what makes the coin valuable. And when I say consensus about the rules, it means that there's only a fixed number of things that you can do with, for example, the Bitcoin blockchain, right? You can do transactions, etc. And the reason why I'm bringing this up is this is the foundation and one of the reasons why Ethereum has even been developed, because with the Bitcoin blockchain, it's a very transactional blockchain, and the consensus about history, what this means, and and the reason why I'm touching upon this now is we're going to talk a little bit about hashing, is that the way the blocks are added to the blockchain, okay, is such that one block, so a new block, is actually the product of the previous block, which is a product of the previous block, so the goes all the way back to block 0, to the initial part of the blockchain, to the first block that was created on the Bitcoin blockchain back in 2008. And so the reason is that each time a new block is added, there's a couple steps that have to happen, right? So there are rules for adding it, and each block is based on and utilizes the hash of the previous block. So if things start to go off or things start to do what's called a fork, and you try to add a new block, there's a consensus over which is the prevailing fork. And I do a whole talk about this topic, so I'm not going to really go into it too much now on how that actually works, because that is 90 minutes on its own. But the interesting thing about it is because of the rules, we are able to then figure out which is the fork that's going to continue, and then everything then moves over to that fork. So let's leave it at that for now. You're welcome to reach out to me, and I can point you to some information later if you have more questions about it. So, the nodes on the Bitcoin blockchain, and so Bitcoin, the underlying technology is blockchain. A node provides one or more services, and so the services basically are, the scope of what you can do with Bitcoin. So the different aspects are routing, storing on the blockchain, mining, wallet management. So there's really just a limited number of services that you can do. And there's payment verification, simplified payment verification nodes, and there are other nodes that exist for running specialized protocols. But really, the idea of Bitcoin was to represent a cryptocurrency, okay, and keep track of transactions, payments, and different, routing, etc., of what's going on that network. And being decentralized, it was important from, not just important, imperative is a better word, since the very beginning of the first block that was issued, that this cannot be corrupted. So the other idea, the other term that is used a lot with blockchain and cryptocurrency is the idea of immutable transactions. So once a transaction is committed to the blockchain, it doesn't change, because by changing, if anything in that block were to change, it would invalidate every other block going backwards. All right, so this graph comes out of Mastering Bitcoin, and I'm not going to go into it in too much detail other than to say these are, this is kind of what was covered on the previous page, and it's just a, pictorial representation of this. So, all right, so understanding hashing is, it's not imperative, and it's certainly not imperative to using Bitcoin, but it's good to understand what hashing is. So, I mean, if you have a background in computer science, I do. By the way, I didn't really give you too much of my background when we started because we got started a little late due to the technical issues that we had. But I used to teach computer science at UC Santa Barbara, and I also have undergraduate and graduate degrees in computer science. And hashing was something I learned really early on with data structures, and you were using in order to build hash tables, which was, you know, one method for speeding up access and managing data. So hashing functions have been around for a long time. And really, the main thing to understand about hashing at this stage is that hashing takes a string, some arbitrary input that could be different sizes, right? It could be a single word, it could be an entire book, and it converts it to an output of a fixed size. And the reason why this is important is that you don't want to be storing things of varying sizes on the blockchain. You want it to be in a particular block. It needs to be of a fixed size. So what hashing does is that it converts whatever that input is, right, into a string. And so with Bitcoin, as well as with Ethereum, the size of the string that's being used is 256 bits, which is 32 bytes, and is usually represented by a 64 digit number. So the the size of a block then, okay, in terms of the content, the information that comes in that hash, is only ever going to be 32 bytes, right? So that is that's important, so that when you have you know, your blockchain, you've got a fixed size of blocks associated with for each block on the blockchain. Okay, so that's really the foundation of that in terms of what's important. So, for example, if I had a message called, you know, that was meet me for dinner tomorrow, or meet me tomorrow for dinner at Carpe Vino, if I ran that through a hashing algorithm, it would give me with a 256 hash, it would give me a 64 digit string that represented that. So, and if even the one character in that string changed, the 64-bit digit, you know, the 64 digit string that was produced from that would be vastly different. And the reason why this is important, again, is because the proof of work calculation takes advantage of this, and it's one of the reasons why we can then trust the blockchain, right? All right, so for example, you know, the sum or the hash, the SHA sum, which is the hash, the sum of the hash, for the message, meet me tomorrow for dinner at Carpe Vino, you know, looks like this. The sum of the word, you know, the dump of the word password is these digits. If I ran this through the hash function, it comes up as 6B, blah, 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 blah. And if I ran password instead of password through the same hashing function, it looks vastly different. And so that's, you know, that's the key. So if somebody corrupts the data portion of a block that has already been committed to the blockchain, you know, the hash of that's going to change. Now, the algorithm for committing a block onto the blockchain actually uses, as I said a couple times already, the previous block. So it's pretty easy once you start. You know, this might be coming in a little bit fast right now for those of you who haven't had experience with this, but if you take a little time and read up on this, once you kind of get it and it clicks, it really all starts to make sense, and it's actually very beautiful. All right, so there's just one or two more little things I want to talk about before talking about Ethereum. One of them is mining, because for a long time, even after I, was working in crypto and blockchain, I kind of really didn't understand mining. I mean, I knew mining was, how blocks were created, but I finally one day just decided to sit down and figure it all out, which was pretty fun. So the initial Coinbase transaction, or the Coinbase transaction, is actually the transaction that adds Bitcoin to the system. So there's a company called Coinbase where you can log in and set up an account and transfer fiat, transfer dollars or pounds or whatever to Coinbase or to another company that's doing very similar, that has a trading platform. And you can go on there and have a wallet and buy cryptocurrency. You can then, if you want, leave your money if you feel safe, or you can transfer your, leave your crypto in your what's called software wallet, so your wallet associated with the account. Or, if you want to, you can transfer it to a hardware wallet. But the point is, when you're using, a hardware wallet or a software wallet, you're going to have both a public and a private key. So you want to make sure that your keys are secure. All right, so mining is the act of adding a block to the blockchain. You can go to Block Explorer and look at the blocks, and then validating a transaction is when you actually look at it's when the transaction. I'm sorry, I've been up for a number of hours, so I'm gonna take a breather. All right, is when the transaction is validated in order to be so the block gets committed to the blockchain. All right, so there is a link here that we have, which is blockchain info, block, etc. And so if you want to go and actually look at the original block, or look at a specific block, you can do here. You can go here, and also if you go to blockchain.com/explorer, which again we have that link up on the Reactor page, the GitHub page. It's one of the links that's on the landing page there. You can explore, you can go back and look at the original blockchain, or Bitcoin block 0. You can see like the timestamp, the hash, etc. So the way that blocks are committed to the blockchain and to the Bitcoin blockchain is through what is called proof of work. And again, I'm not going to spend really much time talking about that today. And I know that there have been a couple other intro to blockchain sessions that we've done through Microsoft Reactor. So I'm sure you can find those online and view them. And it talks in more detail of how this actually works, because it's actually pretty beautiful. When you are able to take some time and really take a look at it. As more blocks are added to a blockchain, it takes longer and longer it becomes more difficult to go through the iterations in order to do the commits. So We're kind of up here now. Back in 2008, we were down here, so it was much faster, and it's basically an exponential curve in terms of the difficulty to mine and create a new block on the Bitcoin blockchain. So that's just kind of a high-level overview. Again, if you have any questions, you can pop them into the Q&A block, and if there's anything, I could take a little pause right now and try to answer that. If not, we're going to then transition over to talk about Ethereum. So, anything? Okay. Well, I hope everybody's enjoying the conversation so far. This is the part where things, I think, really start to get interesting. Ethereum has taken the original Bitcoin concept and has extended it beyond the transactions and the cryptocurrency part. So when I first started to really get involved with blockchain and cryptocurrency back in 2016 and early 2017 was during the time that a lot of ICOs back then, initial coin offerings, were starting to come out, and people were issuing tokens, and there wasn't a lot of regulatory around it. Nobody knew. Everybody, it was all like kind of a little bit the Wild West, which was pretty exciting at the time. But how this all came to be was because of the creator of Ethereum, which is Vitalik Buterin. He wanted to extend the Bitcoin platform to be able to execute essentially these smart contracts, but essentially have a decentralized virtual machine that could execute code when there was a transaction. So if I wanted to develop a app that was utilized for transferring real property, right? And you bought, property from me and we exchanged our currency, I would also want to exchange the deed or the title to that property to you. And so there were all these different types of applications that people could see that they would want to build on the blockchain, but the Bitcoin blockchain didn't support that. And so, the community was not really interested in deviating too much from Satoshi's vision. And so he knew he had to create something new. And so one of the things, so Ethereum hence was developed, and it has a few different premises associated with it that we're going to discuss in the next couple of minutes. But the main one is that it really is a decentralized virtual machine, and it stores data and it executes contracts as part of the, as part of doing transactions on the Ethereum blockchain. And you can spin up your own Ethereum blockchain, and there's multiple blockchains that are out there, both public and private ones. So the cryptocurrency associated with Ethereum is called Ether. And using sort of Ether is a gas, the associated with executing contracts on the Ethereum blockchain is what's called gas, and you need to pay gas in order to execute contracts. And that is one of the mechanisms by which, people don't take advantage of the blockchain and just have their, contracts executing and taking up, everything. So it's, transaction times are also much faster, 10 to 15 seconds usually. So, and I put some useful links on this page, even though you can't click on them while I'm doing the presentation. We'll have them also available. But this is the link to the main workshop resources. It's, again, very useful. There's tons of stuff up there, so I encourage you to go check it out. If you want to follow along with some of the examples that I'm doing today as well, they're all up there, so you can do that if you want. Microsoft has the Azure blockchain service, so you can set up your own account and set up, and run and put applications out on there if you want to. There's a couple more links, ethereum.org and the Wikipedia page for Ethereum, which are also pretty interesting to take a look at. So, the key component to this idea, and if you're a computer scientist, you've probably heard, or, engineer, whatever, mathematician, you've probably heard of the term Turing complete. And essentially what a Turing complete, blockchain is something that can be executed using like a normal programming language. So it's basically a set of instructions that can be executed to do something. I mean, that's really the concept. That's really what you need to understand. So don't get too lost in in that piece of it. And if you've if you have experience coding with other high-level languages that are object-oriented, like C++, Python, etc., Solidity, which is the language that is used to write smart contracts, it'll follow really quickly for you because it's pretty straightforward and it's very similar. So, as I mentioned earlier, just as a car can only go as far as the amount of gas that you have, you need to allocate ether, need to allocate gas to a contract so that it can be executed. So if you put too little on there, it won't get executed. If you put more than you need on there, usually what happens is there's a bunch of nodes and they're looking for stuff to do, and someone will probably take your contract and execute it. But the reason why it's in this, the reason why it was designed into Ethereum is so that people wouldn't try to do these unending or very computationally intensive tasks without compensating miners for the work that they're doing. All right, so just this is kind of the last slide before we start to go into doing the example, and are starting to look at the actual tools that we need. So this is the blockchain dictionary. There's a bunch of terms and definitions. I just kept this in here, not because I want to go through it in any detail, because of course that would take the entire time. But it's a good reference if you want to just kind of get familiar with the terms of, that you'll use if you want to start developing blockchain applications, or what we call decentralized apps, or dApps, or other types of blockchain or crypto, platform systems, etc. So. All right, so we're gonna kind of start talking about the tools, and the first tool I just wanted to talk about is called Truffle, and it is basically a framework for Ethereum that allows you to build contracts and deploy them before, and test them locally before you want to deploy them to public ledgers where they'll incur real costs. So it's a nice little testing environment if you want to develop locally and test. So associated with Truffle, and the link is trufflesuite.com, is another tool called Ganache, or Ganache. And Ganache is a way to quickly fire up a personal blockchain. So the Truffle Suite introduces a very realistic public ledger experience without having to actually go to a public ledger, which of course you don't want to do until everything's been fully tested, et cetera. But you can, it gives you a really nice environment to do testing. And both, going back to the Ganache, the Truffle page. So, you know, you need to install Truffle either from a terminal window, or it's also integrated into the VS Code Studio. If you have any problems installing it from the command line, then you might need to do it as super user. So using sudo sudo will help you do that. All right, and Ganache has a command line interface for the client, as well as you can install it and, you know, click on the icon and bring up the app interface as well. All right, if you also, I wanted to just bring this up. We're not going to really take a look at it in any detail, but if you want to, you know, do some tests, and if you want to, you know, get going also without installing a bunch of stuff on your machine, you can go to Remix, and it just has a web interface for and has an IDE in there, so you can write or you can input. It connects with Git and a few others. And over here on the side, you know, you can, it's got some samples that just come up when you go directly to it. Sorry, I didn't mean to click over yet. It keeps doing that. And you can compile, and you can deploy, and you can use plugins as well. So if you just want to go and play without installing anything on your machine, you can do that with Remix as well. It's pretty easy to use. All right, so the Solidity documentation is out there. Solidity is the language that we use to write smart contracts, and everything is available on, you know, on solidity.io. All of the documentation. It's pretty, like I said, pretty straightforward. It was influenced by C++, Python, and JavaScript. It's, you know, object-oriented, high-level language for implementing smart contracts. So, again, if you already have expertise with these other languages, you're going to find it very easy to use. And so what really is a smart contract? It's essentially business logic that runs on the network. And, you know, so essentially what we have with Ethereum that we didn't have with the Bitcoin blockchain is a decentralized virtual machine that is extensible or extendable. I'm using the term extensible to, you know, different types of applications. So people who write applications for, you know, on Ethereum that, you know, can then be run or used, you know, you'll hear the term dApp, and that term actually refers to decentralized apps, so dApp. All right, so the structures, again, are pretty straightforward. You're going to see this when we go through the examples. The basic structures are supported by, that are supported by Solidity include state variables, functions, function modifiers, events, structured types, enumerated types, and mappings. So, and we'll go through an example. We're going to be going through some examples, actually. All right, so I'm going to jump off of the presentation here, and we will, let me close this, and we can, look at, how do we use this in practice, and what is it really useful for. So, all right, so I feel like I've been running off at the mouth. It's a little difficult to do these, reactors remotely, because normally I can see everybody and, interface with you if we were in person. So if there are any questions or anything that you want to talk about or ask about, please feel free. Now that we're getting into the example part, I think that it'll start to also come together. And again, if you want to follow along with what I'm doing on your own machines, feel free to try it out. And that way, if you have any questions, you can ask me. So if I'm going to quickly go to, let me bring up a browser window. All right. Let me just bring this up. Okay. So in order to get started, you want to make sure that you have, the right environment. So you can either do it through the VS Code platform, or you can install directly. So I actually have both on my machine. So I installed Truffle Suite onto my machine, and I can use it both through directly through VS Code or go and access it through a terminal window. So I'm going to bring up a terminal window. I'm not sure why that's not showing up. Where's my terminal? Oh, here. Let me do that quickly. Sorry, I'm just getting things going here. All right, sorry for the delay. Okay, so I just wanted to bring up a terminal window so you could see, what's happening if you want to do this outside of the VS Code. So if I go to the Truffle Suite and I look at the different, the different tools that are out there, there's Truffle, which is the development environment and the testing framework for developing a blockchain, applications on the machine. There's Ganache, which is a one-click blockchain, is what it says. And they're pretty easy to install. So if you look here and you go to Truffle, you can see you just do an npm install truffle-g, so you can just install that directly. I already have it on my machine here, but it takes just a few minutes, so, or not even a few minutes, but it's really quick to install. I can just quickly reinstall it. This will probably complain because I didn't sudo it. So here we go. Oh, looks like it's doing it. Oh no, it complained. E-access. So if that's the case on yours, you would have to then install it. And so let me put in my password. All right. So that's gonna happen pretty quickly. Oh, it's complaining about something. All right. Hope everything doesn't break now. One of the things about it still being relatively new, I will warn you that with both, with Ethereum and a lot of these tools, they are being updated relatively frequently. So sometimes, I'll have something that runs and, I'll have to like re-init or change some config stuff. So just bear with it, if you need it. So, and then the other thing I'm gonna just quickly, before we get into looking, I'm just gonna start up a Ganache client so you can see what it looks like. And I've already installed Ganache. So basically the client will give you, a number of wallets with some money, with some ETH, with some gas in there. And here are your private keys and your mnemonic. Again, if you were doing this, in any kind of real way, you would want to keep this private. It has like the gas price limit and a few other things. And the one key you need to look for is that, and we'll look at this when we start to look at the code in a moment, that when it sets up the client, it is listening on a port. I have it listening on localhost port 8545. If I use the Ganache UI, the Ganache application, and bring it up, it actually is predefined for for port 7545. So that's like the one difference if you're going to be running this from the command line versus running it from the Ganache app. So. All right, so I've got the Blockopoly sample that I've kind of got partially coded up here. I do want to show you some other things with respect to running the blockchain development kit. And so I'll click on that. So I'm in Virtual Studio Code. So I'm in VS Code. And here, these are for the extensions. All right. So if I click on the blockchain development kit, environment C, I have it already installed. I could uninstall it and reinstall it. I'm not going to do that right now because there are some other dependencies that I've already installed. And if I kind of go through that, I'll have to reinstall those as well. And it's not a lot, but it's just, I had to do a couple things with assertions, etc. So yeah, but once I encourage you to, if you're not using VS Studio, to download it and take a look at this. It's a nice environment. Everything's integrated. If you are using VS Code, it actually all of this is already integrated, and so it makes it really nice. So you can create a new product, and one of the frameworks that it leverages is the Truffle Suite. So if you want to start doing some coding on smart contracts within VS Code, it's pretty straightforward to get going. And when you want to bring up the command palette, so a shortcut to that is Command Shift P. And so if you come into here, you can click on a new Solidity project, and what that'll do is it'll try to, set that up. You need an empty directory because it puts a bunch of files in there. So if I was going to do this here, I might want to, create a new directory called new test. All right, so now I have new test on my desktop. So if I click that and I select that to do the project path, the reason why I'm doing this is so that you can see, I hope it's big enough. If you need me to increase the font size on my screen, let us know. So it takes a couple minutes to create a new project, but I want to do this so that we can walk through the files that get created and I can describe to you what they are. And then as soon as we get through that, I'll go back through the other sample that we have with the bank and et cetera. So again, I apologize if I'm speaking really fast. I know this is being condensed into a short amount of time, but I think it is interesting to get going. I'm not sure why this is taking so long. It's taking a few more minutes than I have expected it to. So I'm going to let that run. All right, I must have. There we go. All right, let's just. Okay, I'm letting that just happen in the background. All right, so I'm going to go back to the terminal window one more time, just so that we can kind of look at the files. Okay, here we have new tests now. What's up? Okay, that do get created. So when I am creating a new blockchain environment, I get a few files that are created by doing the init. If I did it from the command line, I would type in truffle init. And it's going to complain because I'm in my default folder, and I believe I already have some stuff in there. However, it creates these files that, let's see, I'm just going to kill that, that give us a place to start. And so you'll see at the top here, it has the pragma, which says what version of Solidity. I'm going to have to change that because of the differences with the compiler and the setup that I actually have running locally. So that's the one. And so this contract hello blockchain just has is a sample piece of code that you can take a look at and use as a place to start or as an example. So we're creating a contract called hello blockchain. There are two states. There's a request and a respond. Okay, and the state type can be either request or respond, and then there are two addresses, the requester and the responder. This is pretty straightforward. We'll have a couple of strings, the request message and the response message, and so there is an event that basically tells us whether or not the state is changed from request to respond. A constructor function that starts and sets it up as the state being request, and a send request message and a send response message. So it's pretty straightforward. It's very simple. The other file that gets created when we do an init is a migration. So this basically gives us the code that we need to do the migration out there. And then under the migrations, they usually start with the initial migration, which is just setting up the migration, and a deployer. So this actually deploys the contract. There are some node modules which are also created when we do the creation, and there's a little test case that we get as part of this. So I'm going to go back and reopen my Blockopoly workspace. Hopefully that opens up. Actually, I think I wrote it with this. Okay, here, let's bring that up. All right, so under here we have the bank contract. Okay, so when I pull this up, a couple things that are different. I mentioned earlier that we needed to add this license identifier here. So this basically says that we're using the MIT license, and the version of the Solidity compiler is from 0.422 to 0.8, which is, I think, the most recent one. All right, so this is simply an example of a couple things, and we'll just kind of talk through it. One of the keys, and I mentioned this earlier, so I'm referring back to it. So if I am deploying this, one of the things that comes up when we do a truffle init is this config file. And in this particular config file, we've got, we're running this, we're doing on the development blockchain. And I'm going to just open the terminal window here. And this is going to be running on localhost with port 8545. And so this one would run with the desktop version of there we go. Okay, let's just make sure we have this here. Okay, so build, change law contracts. All right, so all right. Okay, so when if I were to use the Ganache client or the Ganache client for this one, I would then use the one from the command line, because that actually listens on port 8545. If I were to use it through Ganache app, it would, the Ganache UI, I would have to change that to 7545. All right, so walking through this, with developing this contract, again, a bank in our Blockopoly. I'm going to bring up our bank contract README. All right, so again, it discusses the steps. So you can go here. It's under Reactors, Workshop, Emerging Tech, Blockchain, Building Smart Contracts for Blockopoly. All right. So the steps to do this, we went through Truffle init and VS Code in order to create the directory. You can use either a regular text editor or VS Code, and then we're adding the bank based on the code here. I don't really have time to, write this from scratch, but I will go through it with you. Because it's we're doing these blocks, I need to mint the blocks, so I'm going to have a minter. And I'm going to have an event because of the bank. The bank has a from and an at to address and an amount. Okay, so if I want to send money from and do a transaction, I need a address that I'm getting it from and an address that I'm sending it to and an amount. We need to build a constructor. So this is run when the contract is created. Okay. And then I have a function called mint, which takes a receiver. Okay. So initially I'm going to be running this to put some money into the bank. So the receiver is going to take an amount. And the message is going to be that for this particular function is that the sender is the minter, and we're going to make sure that the amount that they're sending is less than some really large number. So if that happens, if somebody tries to mint this with an enormous amount of money, and then the balances, so are going to be, incremented by the amount. So, and we're going to have a function called send money, and then we're also going to have a function called get balance. So those are the basic fundamentals of having that. And so when I look here, I'm running the blockchain on the development, and so I'm going to try to build this contract, and I can build it directly, by doing a right click and, clicking build, or I can come to the command line I'm building right now. So it's going to take a couple minutes. Or a couple moments, hopefully not a couple minutes, to build. And while we're building that, I'm going to show you the migrations and what they look like. So the initial migration is structured, and the way that it works is that there's the this isn't really enforced as much as it is the standard, that the first migration starts with the numeric digit 1, and the second one is with 2. So the first one, we've got the migration, the initial migration, and then the second one is the contract migration. So first we deploy the migration, and then we deploy the contract, which is the bank. And then I wrote a little test here or actually I didn't write it. I'm utilizing the test that we have here in our, that we have here in the reactor folder. So under here, it says that we require the bank. Okay, that's good. And then we require truffle assertions. So I'm not sure that I have installed it, so I'm going to install that right now. All right. Oh, I put the hyphen in front. Okay. All right. I'm not sure why that's not. npm install. Okay, specify the formatted file. Okay. I must have typed it wrong. Truffle. All right. I already had one installed, so it's rolling it back and it's reinstalling it. The reason why I'm adding that here is and doing this is that I don't believe it was listed on the READMEs under building Blockopoly, so I just wanted to go that. Okay, so here if we look at okay, it actually does say to install it. All right. Okay, so basically that is is that we've talked about that. We talked about the config, so I'm going to then try to deploy. So all right, and I can do this either from the command line if I wanted to, or I can run it, you know, through the terminal on here. And so when I say truffle deploy, it is asking, all right, it is looking for my Ethereum client, which I don't think I have running. So I'm gonna run the client from the command line. All right, so I've just restarted my test blockchain, my client, and now I'm going to try to do that again. Hopefully I won't have any problems. Okay, there we go. So we're rocking and rolling. If you can see what's going on up here. I don't know that I'm going to have time to, you know, redeploy this. We're kind of getting to the end, but you know, here we're listening on localhost port 8545, and then we can see that when we ran this, the initial blocks, I hope I just saw a message saying the network was bad quality, got executed. And so now I am going to do the test for our test folder. And so that's our test. And let's see, give that a moment. All right. Okay, so looking down here, we just, I mean, this isn't, you know, super exciting. It's something, it's showing the testing of the bank, and it shows that we also tested the disallowed actions of the bank. And I didn't really go through this this test in too much detail, but it's pretty straightforward. I'm going to quickly go through it as I realized I thought I had gone through it, and I apologize for not going through it earlier before running this, but basically when I am running, when I'm writing the test, I am requiring, I think I got distracted when I installed the truffle assertions. So the contract, so we're calling the contract with a variable called accounts, and we are testing the bank, okay? And so basically there was that little delay that I had mentioned earlier. So we are waiting for the bank contract to be deployed, and then we're minting the account with 1,000, account one with 1,000 tokens. And then we wait and we send on the next request, which is to send money from account 1 to account 2 to 100 tokens. Then we get the balance, and it would say, you know, if you know what the balance is, and then we are checking to see that, you know, the testing of disallowed actions in here, and we're asserting different failures, and of course none of the failures came up while we ran the test. So I'm sorry, this is that we didn't have more time to go into more detail here. I did want to show you how to use the tools so that you can go and play with this on your own. I encourage you to do so. At this point, I think I'm going to wrap it up. And, you know, hopefully we have a couple minutes for questions before people really start to drop off. Is there any questions? Okay, I'm seeing someone was unhappy that it was supposed to be on Solidity, so let's see. No, the slides will be provided, or they have been provided, but I can make them more available also. Okay, Emma, are we wrapping up? I can't hear you.
Yeah, I think that's just about on time for today. So yeah, thank you everyone for attending, and thank you Manette as well for delivering today's session. It's been great to have you. And yeah, hopefully see you all at the next Reactor session. You can see all of our upcoming sessions on our meetup group.
Okay. Emma, can I chat with you for a moment after after we go off being live?
Yeah, of course. I'll just end the session now. So thanks again, everyone, for attending, and hope to see you all back again soon. Thanks.